of miles across the Indian Ocean. And then Wegener saw it all clearly. He realized that all the continents in the world had once formed a giant single landmass, the Pangea, that the plants and animals found on opposite sides of the world had once shared the same home. Then, over hundreds of millions of years, Pangea had split apart, and its jigsaw pieces had drifted to their present locations. Wegener called his theory continental drift. Wegener wasn't the first scientist to speculate that the Earth had once been dominated by a supercontinent, but he was the first to pull together all the evidence and make a strong case for it. Unfortunately, his peers weren't very receptive. There was no mechanism to explain how the continents might plow through the oceans. Continental drift was just too incredible to believe.
At one time. A good example of this are the coastlines of South America and Africa. When you compare them, you will find, with just a little bit of adjustment, that they match quite nicely, like pieces of a jigsaw puzzle. And see how the island of Madagascar slides next to Africa. The same goes for North America. Its eastern coastline fits nicely around portions of Africa. People have been noticing these kinds of shoreline similarities for a long time. In the early 1900s, German scientist Alfred Wegener believed that in the distant past, later determined to be about 200 million years ago, the continents had been joined in a single supercontinent Wegener called Pangea, and then had split apart, moving ever so slowly around the globe, until they reached their present-day positions. Wegener called his theory of moving continents continental drift, and he offered additional evidence. Wegener found fossils of nearly identical animals in both South America and Africa.
Hundreds of millions of years, Pangea had split apart, and its jigsaw pieces had drifted to their present locations. Wegener called his theory continental drift. Wegener wasn't the first scientist to speculate that the Earth had once been dominated by a supercontinent, but he was the first to pull together all the evidence and make a strong case for it. Unfortunately, his peers weren't very receptive. There was no mechanism to explain how the continents might plow through the oceans. Continental drift was just too incredible to believe.
The heart of the Earth, its inner core, is a solid ball of iron and nickel. Here the pressure is so high it never melts, despite the intense heat of 3,700 degrees Celsius. The outer core is under less pressure, so it is molten. This is enclosed by a deep layer of hot rocks called silicates. This is the mantle, and it's 3,000 kilometers thick. The surface is hard and forms a solid crust. If the Earth was a peach, this crust would be as thin as its skin. The Earth's crust is cracked and brittle, like an eggshell. It's made up of several segments called tectonic plates. There are two kinds of crust. Continental crust forms the great landmasses of the world. This is thick. These rocks are made of ancient lightweight substances like granite. Some were formed almost 4,000 million years ago. Oceanic crust, which lies under the planet's great oceans, is much thinner. Oceanic rocks like basalt are heavy and much younger, 1/20th the age of continental rock.
It happens because hot rock rises, heated by the Earth's core. Near the surface, the rock spreads in two directions and goes sideways. It begins to lose heat. Eventually, the much cooler rock sinks back down. Through this spreading process, the Earth's crust is very slowly dragged apart, and it's this that ultimately causes the continents to move. Where the plates collide, the rock on the seafloor containing carbon from the dead plankton is carried deep into the Earth. As it descends, this layer of rock is heated, so the rock melts, releasing carbon dioxide. And gas is returned back into the atmosphere during an eruption. The remarkable sight.
Theory holds that hotspots may begin as a blowtorch-like thermal perturbation in a zone between the liquid outer core and overlying mantle about 2,900 kilometers deep. The thermal plume allows solid, yet mobile mantle to rise very slowly and convect outward, burst the entire mantle. Let's zoom in to look at the onset of hotspot volcanism beneath a moving plate. As each pocket of melt stalls, its heat is transferred to adjacent rock. This transfer continues to the base of the tectonic plate, where decreased pressure facilitates rock melting. The magma that forms at the base of this plate rises through the plate in a network of cracks and shallow chambers and erupts on the surface. Over hundreds of thousands of years, large volcanoes build on top of the plate. The weight of the volcanoes bends the plate downward. Volcanoes that spent their constructive life over the thermal plume slowly get rafted away on the moving plate, and new volcanoes build in their place. Multiple dikes can feed several volcanoes from separate conduits. The moving plate drags the thermal plume with it. This can explain why volcanoes can erupt again after centuries of quiescence, even after they have moved off the center of the hotspot. However, erosion greatly outpaces volcanism as eruptions wane, and the buoyant effect of the plume diminishes, allowing the volcano to subside.
Geologists came up with a new theory. They believe that inside the Earth there are hot spots where hot rocks from near the core rise up through the mantle. Near the surface, these rocks melt, burning through the crust to form volcanoes. As a plate moves slowly across a hot spot, Over millions of years, a line of volcanoes forms. One place this is happening is in the middle of the Pacific Plate. Here, the volcanic islands of Hawaii are still being formed. The biggest island has 5 volcanoes. One of them is
The ocean floor is creeping gradually northwest at 3 inches a year, but the hot spot under it doesn't move. A volcanic island builds up, but as it moves away from the hot spot, it is cut off from the source of lava and dies. Over the hot spot, a new volcano forms. But if the big island is growing, then what's happening to the island of Oahu? Oahu should be shield-shaped,